All right, so let's deal with a problem dealing with the different reference frames and relating between the two. So I have a barn here that is 10 meters long. This is the rest length, so the proper length right there, 10 meters. I have a pole here that's 16 meters long as in its proper length right there. So if I just put them side by side, if I had barn here, I'd have the pole right there. So where that's 0 meters, 10 meters, 16 meters. This assumes they're in the same reference frame right here so that their lengths are measured equally. So actually the terms, they're both at rest relative to each other. So if instead this pole is moving at 0.8, so beta is 0.866. That means that the speed of the pole is 0.866 times the speed of light. And if you work through the math there, so gamma is 1 over the square root of 1 minus beta squared, we end up with something that is around 2. And just please make sure that you can get that. So using the calculator, we have beta is 0.866. We will square that. We will subtract it from 1 and take the square root and then the reciprocal. And so there's a shadow there, but close enough to 2. All right, so gamma is about 2. So as this thing is moving in here, so let's deal with, we have basically 2 doors on this. There's a left door and then there's a right door to this barn. And so when the pole is inside, when this part of the pole is inside this door right here, then this door closes, and we assume it closes instantly. So in the barn frame, x1, t1, this is the moment that the left door closes. That's 0 meters and 0 microseconds. So this is when we're basically establishing from the barn point of view, this is my origin. And when the left door closes, we establish that's when time is equal to 0 for the barn. The right door closes. At some time x2, t2. And that's going to happen at 10 meters and 0 meters microseconds. So what we're saying is that in the barn frame, from the barn's point of view, the pole will be completely inside, and that these 2 doors are going to close at the exact same time. So from the barn's point of view, doors close at the exact same time. And then the last part from the barn frame, or the barn point of view, we'll have some point x3, t3. And this is when the pole smashes into right door, to RD. And this will happen at the position is 10 meters. This is when the pole hits over here. And the time happens at, well, we know how fast this thing is traveling, and we just need to figure out how far it is going to go. When the pole is inside here, since gamma is 2, from the barn's point of view, the pole is only 8 meters long. So that's 10 meters. So if the barn sees the pole as 8 meters long, not only sees it, but from its point of view, it is 8 meters long. And this right here is the 2 meters it has to travel. And so the time, I know that distance is equal to rate times time. And so the time it should take would be delta x over v, which is the 2 meters divided by how fast the pole was going, which is 0.866 times 3 times the speed of light. And you work that out on the calculator. We have 2.866 divided, and then 3e8 divided, and we end up with 7.698 times 10 to the negative ninth seconds, which is 7.7 nanoseconds. And given that, you know what, we're going to make this 0 nanoseconds here. And so this event's going to happen 7.7 nanoseconds. So from the bar's point of view, the right side will smash into the right side of the pole, will hit the right side of the door at 7.7 nanoseconds. Now let's see what happens from the pole's point of view. And let me shift this a little bit so that that actually is in screen there. So from the pole's point of view, x prime is equal to gamma x minus vt, and t prime is equal to gamma t minus v over c squared x. We do need to establish sort of a reference frame here. So if this is my pole right here, this is the right side of the pole, and this is the left side of the pole. I'm going to make this as x prime is equal to 0. So from the reference frame here, this is my origin in terms of the pole. And I'm going to make x prime 1, t prime 1 equal to 0, 0, 0 meters, and 0 nanoseconds. And this is when left door closes. So I'm synchronizing the two systems for when the left door closes. That is, the origins are in sync and the times are in sync. So x2 prime is going to be equal to gamma x2 minus vt2, which is 2 times x2. So if we flash back over to here, x2, there's x2, my t2. So that would be 10 minus v, which is 0.866 times the speed of light, times time, which was 0 nanoseconds. And so this would be 20 meters. And so x2 prime, t2 prime is going to be equal to 20 meters. We still need to figure out the time part. But again, this is when the right door closes. So the right door closes after the pole is already past the barn. So T2 prime is equal to gamma times T, which was 0, minus V over C squared times X, which was 10. I know V over C is 0.866. That equals 2 times 0.866 over the speed of light, 3 times 10 to the 8th times 10, and work that out on the calculator. So we have 2, enter 0.866 times 3e8 divided by 10 times, and we end up with 57.7 nanoseconds. Negative. So negative 57.7 nanoseconds. So from the pole's point of view, the right door is closing before the left door closes. And then it smashes, so now we're into x3, so x3 prime t3 prime equals, and so this is the door smashes. The right door is smashed or hit by the pole. And so we have, I know that x3 t3 is equal to 10 meters and 7.7 nanoseconds. That's what we did before. And so x3 prime is equal to 2 times x2, times x3, which is 10, minus v 0.866 times the speed of light, times 7.7 times 10 to the negative 9th seconds. And work that out in the calculator. We end up with, 0.866, 3 times 10 to the 8th, 7.7 times 10 to the negative ninth. 7.79 negative times, that is negative 10 plus 2 times. And so we get 16 meters. The calculator's got some rounding issues in there, but it's 16 meters. And then T3 prime, which makes sense because we set our convention when the left door closes and the pole is 16 meters long. So, 16 meters makes sense there. And T3 becomes 2 times, again, plugging into my formula up here. The time was 7.7 times 10 to the negative ninth minus V over C squared, which is 0.866 over 3 times 10 to the eighth times 10. So you work this out on your calculator and you end up with negative 42.3 nanoseconds, which means that the third event, in other words, the pole smashing into the right side door, happens at, and there's a decimal point there, happens at 16 meters, negative 42.3 nanoseconds. So from the Barnes point of view, what happens is that the left and right door, let's bring that back, the left and right door close at the exact same time, and then 7.7 nanoseconds later, the pole smashes into it. From the pole's point of view, the first thing that happens is that the right door closes, then the pole smashes into the right door, and then the left door closes. So we have two different points of view, and we have two different order of events. They do not necessarily happen at the same time. Or actually, not necessarily, they don't happen at the same time. So this is some of the really bizarre stuff dealing with special relativity, and at this point there's enough evidence to support it. So it just seems to be the way that nature works, as strange as it might be.